Hello, class. Welcome to the next segment in the Week 13 material. And in this segment, we're going to sort of build on what we talked about in the previous segment, where in the previous segment, we talked about how to get information out of a NetCDF file using the command line. And in this segment, we'll talk about how you can get information out of a NetCDF file using a Python program. So with that, we'll go ahead and get on with it. And this Python program is in fact located on the class server. So let's get on the class server. There we go. Then I'll go ahead and navigate to it. Put this up in GNE. And there we go. So here's our Python program. And let's just go ahead and walk through some of the stuff that we have inside this Python program. So first of all, we have import NumPy. So as we'll see later on, the information we get from the Python program will actually be Python arrays, that is NumPy arrays. So we're going to need the NumPy module to work with those. This matplotlib, we don't actually need that for what we're doing right now, but this will become important later on when we actually try to start plotting information. And then the other thing is this thing called a NetCDF4 module. So hopefully you guys remember how this syntax works. From NetCDF4, we are in fact importing a specific function called dataset, and this allows us to reference this function within our program without having to type the name of the module out first when we go to call the dataset function. So that's how this setup goes. So from NetCDF4 means we're calling the NetCDF4 module, and then we're saying import dataset, and then when the program sees dataset, it knows we're talking about the dataset function contained within NetCDF4 module. And in fact, this dataset function is how you read information in from a NetCDF file into a Python program. And then scrolling down a little bit, we have file name, and this is in fact the file path leading to our NetCDF file. So starting at the server's home directory, go to data, and then within data, find a file called this, TOS underscore capital O1 underscore 2001-2002.nc. And that's in fact the file path leading to our NetCDF file. And then the way the dataset function works is, here's our dataset function that we referenced up here. So inside the dataset function, we plug in the path leading to our file, which is defined up here. And then this lowercase r indicating that we want to read the contents of that file. And when we read the contents of that file, those contents will in fact be stored in NC, this variable on the left-hand side. And this variable NC allows us to access information from the function that we just called here, or from the NetCDF file itself, I should say. So NC equals dataset file name R. This NC allows us to sort of reference this file when we tell the program to open it using this dataset function. And if we want information about the variables contained within the NetCDF file that we're working with, then we can run this print statement down here in line 19, print nc.variables, and that will in fact give us the information about the variables contained within the NetCDF file. So again, this pretty much does the same thing that we did with the command line, except here we're doing it using a Python program instead of typing commands into the command line. So let's actually go ahead and run this Python program to see what kind of a result we get. So all we're doing right now is printing out nc.variables. Oh, no ampersand there. You can see it actually ran. And you can see it prints out a lot of information that looks pretty similar to what we got from running the commands on the command line. So again, here's our variables that we're interested in, or actually the variable name is up here. It's also down there, but technically we should focus on what's up here. Lon, again, that's our variable, or how the NetCDF file is referencing the longitude values. And then again, here's our lat variable, just like last time. And again, it also includes the units in the output. So longitude, degrees east, that's the units of our longitude values. Latitude units, degrees north, the units for our latitude values. And then our time, again, days since January 1st, 2001. And again, there's the variable name up here, the time variable. And then last but certainly not least, the TOS variable, which stores all our sea surface temperature values. And the units for that are in fact in Kelvin, just like before. And also down here towards the bottom, we get information on how many values. Well, actually, that's contained in here. Sorry, I take that back. So here, this also tells us how many values are contained within the longitude. So again, we got this information from the command line. It was a little bit more organized in the command line, but you can get the same information using Python. So this tells us that there are in fact 180 longitude values, and that's stored in a one-dimensional array. And then 170 latitude values, also one-dimensional array. 24 time values, also one-dimensional array. And then finally down here, three-dimensional array. And I want you to pay very close attention to the order of this array. This 24, the time dimension, is in fact the very first dimension in our array. So if we plug in a value for the first dimension of our array, that is in fact the time number that we're interested in. The second dimension is in fact the latitudes. In fact, you can also get this information from up here. TOS, time, is the first dimension that goes in our array. Latitude is the second dimension that goes in our array, and longitude is the third dimension that goes into our array. And we'll explore that in much greater depth later on, but I do want to go ahead and plant that seed so that you guys are thinking about this as we're progressing through the videos. So again, the first time value that you have, the first dimension that you have is in fact time. The second dimension is latitude, and the third dimension is longitude. When we were thinking about arrays, we were thinking of this in terms of stack number, row number, column number. It might be more helpful to think of this in terms of a time dimension, a latitude, and a longitude as we go forward. And another thing I want to point out while we've got this on the screen is this bit up here that appears at the very beginning. So this right here, order dict, that actually tells us that we are dealing with a Python dictionary. And in the case of this dictionary, our quote-unquote word elements are the NetCDF variable names. So lon, lat is another variable name, and then time is the other variable name. And then the definition element for that dictionary is the actual data itself, all the numerical values stored in the arrays. So in the case of the longitude array, that's our word element, and the definition element of that dictionary is the longitude array itself, the array of all the longitudes. And then same logic holds for the latitudes, the latitude dictionary entry. So latitude is our word element, and our definition element is the one-dimensional array of latitudes. And same thing for the time. And in the case of our sea surface temperature, our variable name is TOS, noted in quotation marks here, and the definition element is in fact a three-dimensional array given by the dimensions up here. Time is the first dimension, latitude is the second dimension, and longitude is the third dimension. And that's what we've got going on down here. In fact, I'll go ahead and uncomment these entries in here so we can sort of focus on this. So this right here accesses the word element, TOS, and gives us back the definition element, which is the three-dimensional array. And that information is then stored on the left-hand side here in a variable that I've called the underscore data. So the underscore data stores that entire three-dimensional array of sea surface temperature values. And then nc.variables lon, that means look up the word element of lon and give us back the definition element, which is the array of longitudes. And then that array then goes in the longitude variable here that's defined in all caps. And then same thing for nc.variables.lat. Look for a word entry called lat, give us back the definition element, which then takes that one-dimensional array and puts it in this variable latitude, which is stored on the left-hand side of this equal sign. And then last but not least, shown this program, the time variable, again, look for a word entry called time and give us back the definition element of that word entry, and then that definition element is an array, a one-dimensional array that goes inside the time variable here. So that is in essence how to get the information out of a NetCDF file using a Python program. And now that these are arrays, we can actually go about the process of analyzing it, sorting through the data, looking at what we might be interested in. So now that we actually have variables and variables that are holding on to arrays of values, now we can actually go about analyzing the data. But before we get too deep into that, I do want to talk a little bit more about what is actually going on inside this Python program and what's going on inside these variables. And that'll be something we'll cover in the next 3 segments. So with that, and we'll see you guys in the next segments where we continue our NetCDF saga.